And it says, a fluorescent tube is filled with mercury vapour at low pressure. In order to emit electromagnetic radiation, the mercury atoms must first be excited. What is meant by an excited atom? Now all it means is it's an atom where the electron is at a higher energy level than ground state. So it just means the electrons, or an electron, is higher energy level than ground state. Okay, so that's all it means by excited. And the next one says, describe the process by which mercury atoms become excited in a fluorescent tube. Now in a fluorescent tube there's a potential difference. So we've got flowing electrons through the tube. So the first thing we've got are electrons flowing through the tube. Now these electrons collide with atoms, or the electrons orbiting the mercury atoms inside the vapour. So these electrons collide with orbiting electrons, and what this does is it raises the orbiting electrons to a higher energy state in the mercury. So this raises the orbiting electrons to a higher energy state. That's in the mercury. So what's the purpose of the coating on the inside of the surface? Well, hopefully we remember that when the mercury atoms become excited, they de-excite and emit a very high energy photon, which is ultraviolet. Now, ultraviolet radiation is bad for us, and these tubes would not give us visible light. So the coating, what it does is it absorbs these high energy UV photons, and they de-excite through different pathways which give out light in the visible. Okay? So we could say that, what's the purpose of the coating? We could say the photons are in the UV part of the spectrum, and these photons are absorbed by the powder, and the powder emits lower energy visible photons. And if we think of this in terms of energy levels, the incident UV photon excites an electron to a very high energy state, but then it falls and de-excites through several transitions, all in the visible. Okay, so the next one, it says, what's the frequency of an emitted photon due to the transition from Ns4 to Ns3? So here we've got an electron which is falling from Ns4 to Ns3. So that means it's going to give off a photon. And what's the frequency of that photon? Now often this might be given in electron volts, but in this particular question it's not. It's very, very straightforward. So what's the difference in the energy levels? So we've got 0.59 times 10 to the minus 18, take away 0.26 times 10 to the minus 18. Now that there equals 0.33 times 10 to the minus 18. Now that energy, that's the energy of our ejected photon. And that must be equal to HF. So if we do F must be 0.33 times 10 to the minus 18 divided by Planck's constant will give us the frequency of the light. And that would come out to be 5 times 10 to the 14 hertz. And the next one says, draw an arrow on the figure to show a transition which emits a photon of a longer wavelength than that emitted in the transition from NS4 to NS3. Now, a longer wavelength has less energy than a shorter wavelength. So something with less energy, there's only one transition there which stands out as having less energy, and it's this one. Because it's a smaller gap, we can see the difference between 0.88 and 0.59 is smaller than 0.33. So that one would be an arrow from n is 3 to n equals 2, and make sure it's in the correct direction, and then you get full marks for that. Okay, another straightforward question.